Okay, so I guess if anybody else wants to raise any questions, please do so. Otherwise, we can get started.
Okay, so yeah, I mean, I can probably start with what we had because it's been a while. I can probably recap, and then we can discuss about it. And so I'll share the screen. Okay. Okay, just a second. Okay, so and also I hope you can see the screen because I'm just trying to keep it as little as possible. The stuff's at the top.
Yep, it looks okay.
Yeah. Okay. So what we have is this is a competition data that we picked up. This competition is over. So this competition happened on Kaggle, and the data we were looking for data which was time series data, and getting engineering time series data was a bit difficult. Fortunately, we decided that we can go to some other time series data which at least will be abundantly available, and that's why we settled down on this sales data. And the sales data comes from this something called M5. So it seems it has been going on for several years, and M1, M2, M3, M4, M5. So this is the data where you have to predict 2 weeks of sales based on data given for about 5 years of sales data that is given. 2 or 3 weeks of sales you have to predict. And this data comes from 10 Walmart stores in the US, spread over 3 states, Texas, California, and Wisconsin. And there are 3 different data sets that they have given us, the calendar, the sales data, and the selling prices. So what did we decide in the initial, after doing some initial analysis, was that let's focus on one store. So in fact, out of the 10 Walmart stores, it's distributed 334 or something like that. So we chose to decide that to focus on a single store and try to analyze how the data is and see if we can later extrapolate it or work with the rest of the data. So to start with, we had downloaded the data from Kaggle, and the data was loaded into Pandas data frames. The 3 Pandas data frames that we have: calendar, sales, and sell prices. So why there are 3 different sets? Calendar contains the days and the details about the days. So what do we have? We'll have a look at each one of them. So the calendar looks like this. So for instance, you have the date, the week number. In fact, they have a very specific format. This is actually the year, and this is the week of that year. The middle 2 digits correspond to the year, that is 2011, and the week of that year. So you have 52 of this. And then the WM is just some number. It's always 1. So I don't remember what it was. And then you have whether a weekday or not. So the weekday and W day are just corresponding ones where the week starts on the Saturday. The month, year, so they have the name of the day. So it's from 1 to 1400 or something like that it goes. And then you have the name of the events, and you have and a few other things. So you have the name of the events, and then snap, and so on and so forth. So what exactly do they correspond to? We have a discussion. So I think I forgot, I didn't send this Jupyter notebook on the Google groups, which I'll probably send it, and Shiva, you probably can share it on your LinkedIn if required. Or what I can do is I can just put this in in a GitHub repo, and then we keep updating it once we do this. I will just keep updating that repo, the file.
Yeah, that would be easiest. Yeah, that would be easiest.
Yeah, I'll do that. I'll do that. I'll probably send you the link by tonight or something.
Okay.
So yeah, and so you have the calendar. We did a bit of analysis of what are the event names, etc. So what we decided was we would put them all together, the calendars, in such a way that we would just look at whether there is an event on that day or not. So in fact, there were two different event names. There were cultural events or not, etc. So I had some ideas on what to do about it, but I haven't really done it. So for instance, there were 4 different types of events, and so I was even, and there were some events where on some days the events were a mix, so cultural plus religion, religious plus sporting, and all these kind of. So I was trying to see if I can give numbers for it, but that's not something I have done. So what I have done, and that is something we had already discussed, was to encode the event in such a way that whether that event exists or not. So it will become a 0 or 1 depending upon whether that event exists or not. And we focus only on California because now we are only focusing on this store called CA1. And so the calendar essentially goes down to this. So what we also did was, instead of the date, which was a string, we converted into a hyphen datetime event. I mean datetime object, and then we had a few other analysis. Like for instance, we dropped everything else because we don't need a month, day, day of the month, and all that. So we just needed the day of the week name, which is important because if it's a Saturday or Monday, it matters. And this date uses the rest of it, and then you also have day, which is the number based on which day it is. Like it starts with D1 to D14 to 19419. So Shiva, this is something I did, which probably I don't know if we discussed or not. So what I did was, instead of having D1, D2.
Yeah, I think you just remove, because you can then have a simple integer row or other integer value. So yeah, that's exactly.
Yeah, so I split that and got this only the day. And then I also removed the last 28 days. And in fact, these 28 or these 4 weeks are for which we are expected to give a prediction. So now at the moment, we are only looking at training data. And so we don't have, for instance, the sales data for the last 4 weeks. And so I'm removing these data on this. So this is the analysis. So finally, what we have is essentially this, where we have the week, week and the year. We have the day of the week. We have whether it is a snap day or not. Snap day usually means it is the day where people with food coupons or the government sponsored food coupons can come and shop. Whether that day had an event or not, what is the date and the day. That is the day, as in this is just a cardinality, like from 1 to 1940. So, and then what we did was just the sales data. It looks something like this. What has is, so we have an ID for each of the item. And so here this evaluation corresponds to whether it's a training data or a test data. So this item ID and ID are essentially not really that useful, because in our case, we only are going to focus on CA1. So there won't be any difference. And so essentially an item ID will tell you what is the department, what is the category. And so, so what we start with saying, we only want the data from CA1. And then we drop all these state IDs, store IDs, etc. Because we know that state is California, store is CA1. So we can drop this. We can also drop ID because it's again not useful for us. So then we have, you see that this one is D1 to D1940 or 41, I think. It's not showing completely. But anyway. So, and then I was trying a few things about creating a item ID in numerical format. I am not sure if I did that completely. So the idea is that so there is the category which is 1, 2, 3, which is hobbies, foods, and household. Then you have department ID. I thought of multiplying it by 1,000. So there was some.
The only thing I can say is this is probably, I mean, I would say do not try to change these keys too much. That even though it is actually like, it may seem a little easier, but usually it does not actually take away too much computing power to actually equate something or even group by something, right? But the problem is that when you want to again compare with what the final result wants, what the actual person wants, then the unbundling can be a bit of a messy thing.
Yeah.
So unless there is some serious value, or rather like a major confusion because of which you want to eliminate that and you want to then replace it with this, it is best to leave this as it is. These kind of IDs, and leave it as it is, because usually they have meanings on the backend database. So for example, if you want to insert it back into the database, you need it in that format. So that's why.
Yeah. I don't think I applied it, but I will check that. I will just confirm that. But I was just trying a few things, and then I did. If you see the next one, I actually did a categorical change, because, of course, that I think is fine, because it's just that there are 3 categories: hobbies, households, and foods. So I converted, instead of them being a string, I changed them to be in the category.
Oh, that's okay. That's all good. Yeah. Anything which is like.
We also have codes, but yeah, go on.
No, anything which is like non-integer, non-number, but is not like. Supposing, for example, if it's address or something like that, which can be totally random. If it is some other kind of string, and if it is limited in the number of unique values it has, it is always, you could consider converting it to some form of categorical value, or even giving it a key for your analysis.
Yeah. Okay. So I think, I am not sure if I really did that completely. I will see. I was trying a few things. I have it on a temporary database, but I didn't really do anything on the main one. So I will go back. Yeah. So do anything. So then the selling prices data I was analyzing. So in selling prices, we have it over a week. So it's very simple to do. What we only focus on the store ID, and you have this as the selling price. So you have the sell price, you have the week, and you have the item ID. That's it. And so at the end, what we have now is this. So we have to do this. So calendar, we have week, W day, snap, events, dates, and day. In the sell prices, we have items, item ID, week, sell price. For that week, what was the sell price for this? And then you have the sales data, which has this. So you have item ID, department ID, and category ID, and you have the, for all these 1944 columns. So now, from now on, we'll have to do something. So this is where we kind of stopped, or at least, we discussed sufficiently that I did some more, and we now have to find a way to merge these. We did a little bit of merging, but it wasn't necessarily clean. So we can probably start afresh.
Yeah. So basically, that last sales thing is like this. We need, for example, if you look for each item ID, we have the number of items sold on all those days, basically 1941 days, right? But if we need to do something of like any kind of price analysis, we also have to find out what was the actual sale that was achieved. So, like for example, if you take the very first hobbies 1001, in day 1932, it sold 2 items, but we would like to know how much actual money we made out of it. So, what is the price on that day? So, for that we need to combine the prices from the previous data frame into this one.
Yeah.
Right. So, we did what we did before. If you look down, we created another one, that is, we created a price of, I think we brought all the days together. So, I mean, I don't know. Is this the end of it?
I will just check. Just a second. I will check where it was. This I actually missed because there was a problem with the Jupyter notebook, and I had to redo everything. That's why I came to this. I will let that open. Just a second. Some problem with prices analyzing this. Sorry. Okay, so I have to run this. Okay, that's fine. So maybe this is where this is the data which we did something, I guess.
Yeah, see that one? I think no, that's not. That is this. No, that is the same thing. I think you have to come down a little. Maybe it is a little later.
Sales train. No.
No, we actually calculated some prices. I remember we calculated some prices. You can do it again. That's okay.
Yeah. Well, let's do it again because I think I missed the consolidation.
Right. So if you go, like for example, so if you scroll up, we need to basically bring a similar data frame in this format. So like for example, if you see hobbies 1001, the best thing would be if we can create another data frame which is almost a mirror of this data frame with all these days, but only instead of the actual count of the items sold, we have the price there, right? So for example, for this first row, if on D1932, we can put the price on that column, then we can simply do a 2 multiplied by the price.
Yeah.
Right. So what we have to do,
we need to now connect this this day from here, which is this day. Find the week corresponding, and then go here. Find the selling price corresponding to it, and then add it to that new data.
Right. So what I would say is this: if you look, for example, so what we need to merge or rather join the data frames in 64 and 65. So if you go up line 65 and the one before that. So these two, right? So what we are going to do is here you have the head of that. So the head of that means we have the WM, year, week, and you have the day, right? So we need these two columns, WM, YR, WK, and the last one, that is day, right? Because day is just D removed from it, right? The last column.
No,
right?
No. What do you mean? This one?
No, because what is happening is...
Oh, yes. Day is just D removed from it. Yes.
That's it. So then we need those two columns. Now, what we have to do is, we have to now say that we have to now merge, like we have to do a join between these two. So for example, if you look at the data frame in 64 and 65, we have to now insert, right, from 64 into 65, the day column, right?
Okay.
So what we are going to do is, first we take, what we do is, we take the data frame that is going to receive the other data frame, right? This is usually called the left data frame, right? And with this left data frame, we are going to join another data frame, which is usually the right data frame. That right data frame will be CalDFCA, right? Okay. So you can go to another, you can have another, what you call, cell somewhere.
Yeah, we'll start here.
So here we have to start with the sales one, which is our left data frame.
Okay. So, I mean, do you want to create a new one, a sell price?
You can copy. You can also do that. Yes, you can do that. Create another one.
Sell prices. So you want to merge sell prices and calendar?
Actually, you'll have to scroll a little down because we can't see that.
Yeah. No, you want to merge sell prices and calendar, right?
Yes, exactly.
I'll put it so you want to do first you want to copy from this? How is it?
Yeah, you can copy.
Yeah. Okay, now for this,
Now we do a join. Now here you have to select. You don't want everything, right? Because we don't want what we need in this. If you just scroll up a little.
So right now we have all of this, which is fine.
That's fine. Then we can just do the entire thing. What we are going to do then, we can done after this. If you come down, you do a join.
Yeah. Is this dot join or how is it?
Yeah, dot join, because it's a method.
Yeah.
So
okay.
Oh.
It's not working anyway.
Okay.
It's working slow. It's slow, but it's happening.
I think now it's. I think maybe a memory error if it's that slow. Okay. So now you see here, this is what it is. The first one is the other, right? So that is usually the other means it is usually it's also called the right data frame. So that will be our first argument. The next one is what is called as on. So on what column are you joining? So usually what happens when you join, one column has to be common because there needs to be some kind of a reference point, right?
Yes.
So now the on column in our case will be WMYR because that is common between both of them. Then how are we going to join it? We are going to, let's say we join it with left. Why? Because we have all the sales prices, right? For this, what do you call it? For those weeks, because we have sell prices. Now, here, what happens is like this. There is a left join, there is a right join, and there is inner join and outer join. Okay, I'll just explain. The left join means that the left data frame, which in this case is sell prices CalDF, is the reference data frame. And we pick out all the rows from the right data frame such that the rows have the same common elements as the row on which column on which we are joining, right? So the left data frame will be complete. The right data frame may have some NaNs, right? It may have some NaNs because there may be some elements that may not exist. Like there may be some values may not exist because we are joining another data frame. This is what happens when you do a left. The right is the exact opposite. In the right data frame becomes the reference and the right data frame is used completely. The left data frame is merged onto that, right? The third is an inner. Inner is like an intersection. Only those rows where all of the elements are available will they appear. So it's like an intersection. And the last one is an outer. Outer is like a union. That means it will just add everything together. So there may be NaNs in both data frames, in the total data frame. Okay. So to get started, let's start with the left one.
Yeah. Okay.
So first we'll have to specify
calendar. This one.
Yeah.
And then on equal to, it should be the name of the this one, right?
Yeah.
So it uses the same thing, yes, on, and we don't have to do anything else.
No, yeah. Now here it won't work, but you can just check it because you can tell the others what the error is. See, you see this error was there. What it means is basically it is saying that there is no columns overlap, no suffix specified. Now, the problem what happened was, there were two things. It was saying that the index, there was one problem is that this WMYRWK, it was saying that should be an index of one of the data frames. Now, in our present case, it is not an index in either data frame, right? And therefore, it was complaining. I do not really see why this should be a problem, but it is. But so anyway, what do you need to do? CalDF CA1 in the 69 row. No, you can just edit.
I think we'll do it in this one.
Okay, fine.
What set index we'll do that.
I would recommend you
the new one that we have created.
Okay, you can do that.
Because I think this is a new one. It's not
exactly.
So WMYRWK. Is this how it is?
Yeah.
Okay. Yeah. Now again, you try the same thing
Yeah,
now.
try it out.
No, it is.
Just check if it has happened in place or is it returned the copy.
Okay. Sorry. Yeah, that's true. No, yeah.
Okay, so just do in place.
Okay, in place is equal to true. Okay, now. Yes.
Now it's okay. So try it out. Yeah,
now
the join works. So, okay. Now, why is it like this? So, you see, we have WM via WK, we have sell price, but you see all the days are all not a number. Okay. Can you do one thing? In this new thing, sell prices, can you check it again? I mean, is it like returning a data frame? This one, is it returning a data frame or is it changing it in place?
No, it's returning data.
No, it is. Okay. So what I can say is just check if in that option, if there is an in place is equal to true.
Yeah, it should be there, I guess. You want to do that in place now? No, there is no in place. So.
So it always returns. Okay.
So I guess we have to. We can put it back into the same. That's not a problem.
Okay.
But right now we don't know what. Okay. So I can just.
No, because Okay, you can just.
Yeah, I will just check what is happening because I doubt this is. So let me just check. It is very much possible. I mean, my doubt was that this doesn't seem to be good. But anyway, we'll just check. .wday, for instance.
The reason why I think this may be a problem, the reason is because we need what is it called? What is the thingy? We need the sell prices, or rather we need the day from the other one, that is cal DFCA1. So setting index of WM via WK may have to be done in cal DFCA1 instead of sell prices. Because
I see what you mean. Yeah. So maybe what I'll do hence here is instead of I will do this again, the copy that I did. I will do the copy again. And instead of set index here for this guy, what we can do rather, I think here when we do this this thing.
Yeah, I think
instead of setting this, I will just do a set index here.
Exactly, because it's not in place anyway.
Yeah. Set index. I will just check what happens. Now I think it's better.
Okay, there's a slight problem. We now have made it into an integer, but we can get rid of that. That's okay.
Yeah. The reason is that
because it's not a number, so
it becomes NaN here.
That's understood.
It becomes NaN here, so it ends up doing it. That has to do with this the last few weeks, because the last 4 weeks you see 18, 19, 20, 21. They should not be there. Maybe what I'll do is I can actually remove it here before I reset it.
I would say let it be. We can reset later. We can reset. Basically, we can do a fill any. We can do a fill any on this one. That would be simpler.
Yeah. No, because anyway, on in general, what we wanted was we don't want. I have already removed this in the calendar.
I see. Okay, go ahead and do that.
Discrepancies happening.
Okay, then
I removed this in calendar, but I didn't remove it in the sale prices. So that is why this whole thing is happening. So what I will just do is, because I think in calendar it was easy to remove simply because there was it was just the last 28 numbers. But in this case, I had to know. So this is the last 4 weeks. So I have. So you how do you address it through indexes? How do you do that? Okay, let me do this. This one is WM. equal to is greater than or equal to.
Well, there's one, I mean, here I would say, since we are here, a simple way to do this rather than using such a number is that we just see, basically we just have to get rid of the NANs on the day rows, right, on the day column, and we need to just convert it to an integer, right? So all we need to do, if you really look, is in that data frame, we just have to do a fill NA where for that column. So I can just tell you, so basically you just have to do a fill NA and set the NAN values of day to 0. And once that is done, you can then convert it to a complete integer.
Yeah, no, but we'll have to also remove this column anyway. These rows, anyway, we have to remove them.
I see.
Because they are actually not useful due to the calendar data. So the thing is, the training data that we have does not have information for this. So when you want to merge the sell prices with the sales data, you won't have the sales data because this is a period where we have to evaluate.
Okay, so looks like then what you did is right. There is just 11618, just less than that, everything is a data frame. The rest you can throw it away.
Yeah, that's a bit easier. I mean, of course, you can do this. I'll just do this.
Yeah, actually less than, because I think 618 will still be.
Yeah. So it's less than. Yeah. I put greater than, and then now it should be fine now. Okay. So, and then this, and let's check. Yeah, it starts and it ends at 17. So now if we do it, it should be fine. Oops. Yeah, there is no NAN. You see.
There you go. So we now have, for every item, we have the price for a particular day. Right?
Yeah.
Right. So what we are going to do now is, let's say for example, I think we did another method which is probably a little messy, but what I was thinking since then is, can we somehow transpose this matrix, or rather this data frame, exactly in the same way as our training data is? So that means for particular hobbies 1001, that kind of thing, is it possible to do a pivot? That is, we arrange all the days for like 897 onwards, whatever, and for each and every one, we convert, or rather, for example, we take the day column, right, for each and every hobbies thing, convert it into a column, right, and we set the sell price according to the column. This is what I was thinking, if it is possible. If that is possible, then we have...
I'm sorry. I didn't clearly understand.
So, for example,
just before that, we can just ask if anybody has question.
Oh yeah, it's been a long time since we've been talking.
Yeah. Does anybody have anything to ask? Any confusion? You can just ask.
Yeah, actually I have one question, but I don't know whether it is right time to ask that, because the last few columns, 28 days you have taken, right? 28 rows. So that like you can train that. You can train that.
Yeah.
So
actually, I don't think we are training for that.
Random rows, or should we need to go with the sequence?
Actually, I think, I don't think we're training for that. I think the challenge is that they want us to tell what will be the result.
Yeah.
And we have to now train it again. We are taking everything except for those last 28 days. We now have to split the remaining part into training and testing data. We have to train, we have to test. After we are satisfied with our test, we then use it for the last 28 days and we give them the result.
So the 28 days was actually not a random number. It is just that they gave the calendar for the entire duration, including the competition test data. But for the competition test data, there are no sales prices because that is what we need to predict. So for our first analysis, we don't want that part because we don't have data for the sales prices. So they do not tell us what is the sale prices because that's what we have to predict. So for the initial analysis where we are focusing on only one shop, etc., that data is useless because we don't have complete information. So that is why we dropped those 28 days. It's at the end. In fact, it's the 2016, the week 18 to week 21. So that is the week, and that's 28 days, and that's why here in this case I actually dropped. If you see, I dropped all the date. I mean, I only kept anything below 11618. This is 2016 and this is 18th week. So this is how the data is arranged, and so this is what we are preserving, so that when we do the analysis, we have all the data for everything.
So basically what happens is like this. This challenge is like this. They have given data for 2 or 3 years and they are asking us to predict what will be the sales for 4 weeks in the future. So for example, it's like this. Supposing we are saying that we want, now today is January 7th, we are saying as a data science, let's say Walmart gives us data and says, you tell us that if this is the kind of price we set in our store, how much sale we will generate in February 2021, right? Now, for that information, we use everything that we have, let's say from 2018 to 2020, right? So we have full data, and now we have to tell them that with this data, this will be your profit or this will be your sale revenue in February 2021 if based on the historical data. So then if they can say that, look, I don't think we are making enough revenue, then we have to come up with another suggestion. Maybe they have to reduce the prices, maybe you have to increase the prices, something like that.
Yeah, that is clear. My doubt is that, like, suppose now if we want to take random rows, I mean, like now we are testing with the last 28 days.
No, that's not. We are not testing.
We are removing last 28 data. So
yeah, we are not testing with 28. Yeah, we are not testing.
We removed and we want to predict those 28 days. Initially, then we will predict the required one which they have given the problem statement.
No. So these 28 days are the days they have given us in the problem statement for us to predict.
Okay.
The 28 days I removed are those that they require, and we are yet to do any sort of partitioning of the data, in fact. So, in fact, you probably are thinking that, okay, in the previous analysis, we split the data into validation and training and validation. We are not yet doing that, in fact. So, this is only to actually prepare the data set. So, this is what we are trying to keep such that, so how much of information can we extract from the data without doing any analysis except some merging and multiplication and all that. This is what we are right now doing. And once we come to the part where we are actually going to run a machine learning algorithm, then we will actually do it, do the splitting. But in fact, at that time, we will also come to an interesting part where how do we split the data, especially for time series. You already noticed something that, we took the last 28 days, and it's typically done that way because you don't predict it for somewhere in between. You try to predict it for the future. So you use the past data to predict future. You don't use the future data to predict past. This is what they don't do it. They do it in time series data. But yeah, those things will come. I think Shiva will come to it. We'll discuss this once we finish this analysis.
Yeah.
Okay.
So now what I was saying is, so this data frame that we have, we want to now bring it in line. If you come down, where is that other data frame with sales training data? This one. Here. So we want to bring that one in line with this, which means it has to have the same structure. So now if you look at the days that we have, if you go up, And if you see the previous one, the one which you merged, the day is a column, right? The day is a column. If we can say that give us the item ID, right, and the sell price, but arrange the sell price with respect to the day. If we can flip that day into a column and the sell price can remain this way, now we have exactly the same structure as the one below, right? And we don't need the first, we don't need the WM, YR, WK anymore, because we don't need that index. That value is useless, and the remaining are also pretty much useless.
Yeah, so there is only one thing, because, okay, so in this, I would say, for instance, in this, one thing we can try is flipping this, saying that, okay, I will transpose this, I'll get a different kind of, it's a bit difficult, but so if I transpose this and use the day as the index, or I mean we can remove, see, for me I wanted to remove this D underscore, okay, and so here we have the day, but this day repeats multiple times.
Does it? Yeah, it will repeat. Yeah, because it will repeat for different. Exactly.
The foods, these items have, there are so many different items. So the day will repeat for each of the items.
Right. That's understandable. Yeah, that's totally understandable. Yeah. So basically what the problem is...
My idea, if you want to merge or if you want to find the amount of money that has been earned, the revenue, if you want to calculate, it would be better to convert this in a way that this becomes a column or the index, and then we can then use the categories, like, okay, this will be huge, because I think this will be also a huge number.
No, they have to be compatible.
To really, because this will be like 3049 categories, I think.
Yeah, no, like that is understandable. Basically, they have to be compatible. Only then can we do like an actual multiplication. So we have basically two data frames which are very similar in structure. That's it. So either we bring the one which you are saying into more of a column form, or like a row form. Instead, right now it's more spread out among columns, or the one below we transpose it into, or rather one above, we transpose into more, we spread this out along rows. See right now a column. See right now this basically it's like one is row long, that means a lot of rows, the other has a lot of columns. So we have to like kind of flip one of them.
So what, I mean, I was trying, I don't know, I was just trying to say, for instance, we probably have to do a sort of inquiry rather than just directly multiplying. Because what will happen is, you take this day and this item. So, I mean, you can go, you start with the item ID and the day, and you use the sell prices to multiply, because here you need to pick the corresponding this number from here. So what we need is somewhere to query the day and the item ID on this. This is what we need. We need to have a capability to.
There is the one problem that I see is, for example, if you remember before we kind of bound up for the day, we were trying to do an apply function, but we were applying on one and we were using the other data frame as a global variable, right? That's, I think, what we were trying to do. Now, the problem with that is that you would typically, when you try to do this, you would not use a global variable in an apply function. That the problem is more of conceptual. If you do this for a job interview, this might pretty much eliminate it, because from a conceptual programming point of view, when you apply a function, the function has to be self-contained, which means it is taking in a particular data, like a data frame, and it is working on the data frame, or the function is receiving as arguments everything it needs, right? Now, in what we are trying to do is more of a kind of dual thing, that is, we are using an apply function, but we are taking external to the function another data frame. That is never usually seen nicely. So what I would say is,
Can you repeat?
okay, so it's like this. Let's take, I have a function, right? This function, we want to do an operation on a data frame, right? So we can write a function and apply it to a data frame, right? This function will work on that data frame. So which means that the data of the function is encapsulated within the function, right? This is called, like, I'm not sure if encapsulation is the right word, probably is, but that's pretty much how it is. So it's like this. A function or any process that you are doing on data should be self-contained. So if there is a function, the function should receive arguments and should use those arguments. If a function is receiving besides the argument a global variable, then the function can break if that global variable is not available.
So what do you mean by global variable here?
So it's like this. Supposing we try to do a query and we try to do an apply function, right? Let's say we do an apply function on this and we calculate. We can do an apply function on this data frame, and then we can check for each day what is the amount sold from the other data frame. We can do a query.
Okay. No, I was actually, I understand, because then it becomes like you are taking something external to this data frame.
Exactly.
But my thought was that we would not be able to do an apply. That's what my thought was.
No, that is you could. I mean, it will be dirty, but you could. We were actually about to do it last time. Remember, we actually wrote the algorithm and things like that. It is possible. It's just a very dirty solution. What we can do,
My thought was to just do it as a separate function which takes these two data frames, and either it's a new data frame or adds a column in one of them to do this analysis.
What I was thinking is, we take, let's say, this data frame and we write a function to spread it out. So like what I'm thinking is this. Let's say, for example, we know...
Do you want to take the control?
Oh, no, that's okay. We can just, because we have just a few minutes, so we can just discuss what we're going to do. So what I'm thinking is this. Let's say, for example, if you come to down to the previous next one, we know that we have days from D1 to D1941, right? This is our last column. So what we have to do is, if for instance we create a loop, we check, that is from D1 to D99 for each and every item, right? We check if that exists in that block. So like, for example, if you come down or up, wherever it is, I don't know where that is, then the other one, the latest, So here, if for each item, hobby is 1001, right? We take each and every hobby, and with each hobby, we now create a separate column, right, from D1 to D1941, and we check if for that day there is a price. If there is a price, then it becomes 9.58. Okay, so initially we start with a blank data frame because all we need is the item ID, right? The cell, the columns, and all of them will be 0. Everything will be 0.
So you want to say right now to focus only on the total expenditure or total revenue for that day.
No. Here now what we're trying to do is, eventually, yes, the total revenue, yes.
Because when you want to do a day-wise analysis, because each day you have 3,000 odd products being sold. I mean, we don't know if all of them are being sold. So for each day we will have 3,049 different columns or whatever you want to call it. And then you have 3,049, and then you will The revenue is the sum of all this.
Right.
So you want to do it per day, per item, or per day, all item together?
I would rather not jump straight to a total calculation. I would like to still have per day for each and every item what was the revenue generated.
Yeah.
That
Yeah.
would still be, because otherwise if we straight away jump to the total, we might miss out on some other analysis that we can do.
Yeah. For instance, in this case, in that case, what we need is essentially now one more column in this data frame, which says which just actually gets the number of items sold here, and then you put it, and then you will get the revenue. So if we do that, I think that will essentially complete what we want as the saying that everything is in one specific data frame, everything in one data frame. So if I just have in another column items sold, that says how many of these items were sold.
Right.
And
either way is okay. That's what I'm saying. Either way is okay. Either you can insert the total sold here, or we can move the price to the other one, whichever is okay.
Yeah. So, but if I see. I mean, but then if you meant to just say you just move the price here.
Yeah.
But we can do that. But then we'll have to come back here to do some analysis in terms of if you want to do any analysis, we'll have to merge this, because you need to know the event and all that, right? So we need to, if you want to do any analysis, we need this, because the date of time of the day and all that is required. I'm sorry, day of the week and all that is required.
I think that can be done, from what I think so, because it's like this. What I'm thinking is that we have to do something like what is called as a pivot. I'll have to actually research this, because I've never done pivot this way. But pivot basically means that when you have a lot of categorical data, right, and you want to arrange your quantitative data according to the categorical data, then you can now arrange your categorical data as columns. So for example, in this case, we have taken day we have taken as integers, but really speaking, they are categorical. It's just a lot of categories, right? We have 1941 categories, but these are actually categorical data. Now, if we can pivot this and make it into a categorical column, then what is happening is we are arranging our entire data frame according to the days. So for each day, we can know what is the sell price, which day it was, that means which day of the week, whether there was an event, what type of event, everything. We can know all those things. So basically for each column, or rather which is a day, there will be several sub-columns. And to that, we can also merge the amount sold. It will be a huge messy thing, but it is possible.
Okay.
We may have to, it's a little messy, so it may, I just Google pivot table, and we can talk about this next week. I mean, it's in data frame, so pandas, yeah. Pivot table.
Yeah.
Pivot table is just that I've never done it for something this big, but it's a very, very nice way of when you have when you have a lot of categorical data and you have some amount of quantitative data. This is a great way to arrange your quantitative data with respect to your categorical data.
Okay.
Yeah.
Okay. I see what you mean.
Yeah.
Yes. Okay. Okay. I will also have a look at it, because it is like group by, but not group by. So,
yeah, it's just that this way you can optionally not use anything. There is something like you can do an aggregate function in some cases when multiple data is found.
This is just to arrange the data.
Exactly.
Group by is to group the data and then do some operations.
Exactly, that's the difference. Yeah.
Okay, that's good. I will also check that. So perhaps next week then we will have an idea of what is happening.
Yeah. So anyway, before we conclude, anyone has any comments or anything?
This Jupyter notebook, will it be, the one that Krishnan is working on, are you sharing that as well in a group or?
So far, no, but we were thinking about putting it like on a GitHub link. I'll post it along with when I post the video.
So that what I'll do is every week I will just, depending upon whoever is working on it, on that week you take that file and then commit a new version after we finish that analysis for that week. So I will send it on a GitHub repo. I'll put it on a GitHub repo today, and then I will share the link to Shiva, and then he will share it on LinkedIn. Okay.
Okay, I guess it was a long session.
Yeah. Okay, good. We have some. We'll see how we get through in this new year.
Yeah.
Most of us are again confined, so okay, go on.
Okay. Okay then. So everyone, see you next week.
See you.
Okay. Bye bye.
Bye.